meant to tell, right? And so this is also true in chemistry, where element and composition are going to be ongoing terms for us, particularly composition. And I find that a lot of chemistry students haven't had this word used this way. And so I think it's really important for me to introduce this in the first unit. Now, I know you've heard the term element as it relates to science and to chemistry before, but composition is a very important word, and it's something that we're going to use a lot. So I want to make sure everybody's on the same footing with that particular word before we go into other stuff. Composition, as you can see on the screen, the arrangement or combination of different elements, which is the same thing as in a piece of music, for example. Simply put, in chemistry, when I say composition, what I mean is, what is it made of? And that is a many-layered question. And so it's important to understand that chemistry is full of layers. And that way, chemistry is like ogres. Anybody with me? Anybody got the reference? Thumbs up if you understand my ogres reference. Nope, totally lost you. No Shrek fans? Right? Ogres are like onions. Onions have layers. All right. So chemistry has layers. No, chemistry is like ogres. All right. And maybe it was a little bit of a stretch. I use it again when we talk about atoms later on, because atoms have layers as well. But when we talk about what is something made of, we can dig into that the same way we've dug into two pieces of art, and we can break down what something is made of. And often we can break it down multiple times. So we can go through multiple layers of what is within the composition of one particular thing that we're looking at. I'll give you a better term for thing in just a minute. Chemistry, the word chemical, I have a big problem with the word chemical in the public domain, and I'm sure you've heard this before. You've probably seen advertising for things that are chemical free, right? That's not possible. Water is a chemical. Air, oxygen is a chemical, all right? So it's not possible for something to be chemical free. But for some people in our society, the word chemical has acquired negative baggage that comes along with it, because what they really mean is toxic chemical or a hazardous chemical. But everything is a chemical. Every substance that we can uniquely identify that has a unique composition, so it's made differently than anything else, is a chemical. So I don't use that word a lot, but I wanted to make sure that you had that before we move forward. It is interchangeable with two other words that I use, but I prefer the other words because of that, because the word chemical has been kind of corrupted in the public domain. All right, so the rest of this, I'm going to go through a real basic vocabulary, and I'm sure that you've seen these words before, so this should be a review. Although this is in the form of notes, do not feel obligated to copy. All I need for you to do is to just listen along. These notes are exactly word for word posted on Canvas in the lesson 6 page. All right, and so if you need to reference them, or if you feel you want to copy these for memory purposes, you can always do that later if you don't want to try to keep up right now. If you are a note taker and you'd like to, that's fine. These are not big slides, but you're not obligated to copy. Okay. All right, so we're going to talk about what we can measure in our universe. That's really what science is about, observing and measuring things in the world around us. Using our senses, but increasingly, of course, as humans, we use technology and we use instruments to observe things that we may not be able to observe with our own 5 senses, right? And so there are only really fundamentally 2 things in the universe, matter and energy, right? Chemistry deals heavily with matter. That's really, if you were going to define what chemistry is, it's essentially, it's the science of matter. It's about the composition of matter. So there's that word again. What is everything made of? Breaking that down and analyzing it on multiple levels. And most of you have already experienced at least some of that information, so you'll have something to build on as we go forward. Energy is related, and you'll see that right away in Unit 2, that we have to use energy to change matter. And so if I want to change matter, I need to have energy involved. They're closely related to each other. In fact, Einstein said that matter and energy are actually just 2 different forms of the same thing in our universe. If it's not matter and it's not energy, then it's empty space. And I think it's very interesting. I find that a lot of students have never made the connection to that word, right? You know what space is, right? We talk about space exploration, outer space. We've talked about that. You've probably seen movies and all those things. But have you ever really thought that that's literally what it means? It's space. It's the space between real things. It's just empty. And it's empty in the sense that it's not, that we don't experience on Earth. So, right, like my cup is empty right now, right? But it isn't really empty, is it? What's in it? Air, right? It's filled with air, and air is a real thing. Air is matter, and it's measurable. And so there's never anything that's really truly empty in our experience except in space. And even then you have to get pretty far away from any object or any source of energy for it to be truly and completely empty. What some people refer to as deep space. And yet, as you'll see in our fourth unit, even though there's nothing that we experience in our daily lives that's truly empty, there is actually a lot of empty space around us. We just can't perceive it. And we'll discuss what that means down the line. But there's some interesting contradictions there that are worth talking about eventually. If we're going to define matter, since chemistry is the science of matter, matter has to have mass and volume. It must have both. It's not possible to have mass without volume, and it's not possible to have volume without mass. Volume without mass would be empty space. Okay? And so that's not something that we consider real or measurable. Right? So mass is defined as the amount of material in something, right? And as we're going to talk about, as you already know, matter is made of atoms, right? And so you could define mass as the number of atoms inside any particular sample, any particular thing that we're talking about. The type of atom has a part to play as well, but mostly it's the number of atoms that determines the mass. Volume is the amount of space that something takes up, an object takes up. And that has to do with the arrangement of the atoms that are inside it. And so those are two different factors that go into understanding matter. So now you can see why I had you focusing on mass and volume when we did the measurement lab. Now that ratio, the ratio of mass to volume, is called density. If you hadn't already picked that up or didn't already know that from prior science classes, it's also mentioned in the Unit 5 notes. So if you haven't done those yet, you'll get a refresher in those notes, or the Lesson 5, sorry, the Lesson 5 notes. The ratio of mass to volume is called density, and density is essentially a constant for any given substance, except when energy comes in, because if you actually heat something up or cool it down, it does affect the density, because matter or energy changes matter. But in the measurement lab, your line should have been very close to a straight line, because the density of water at a constant temperature is constant. It's not supposed to change. And the only reason why it changes is because of our errors in measuring things in there. Questions about that before we go on? And if you do have questions, please feel free to unmute and interrupt me, because I don't have everyone's face on the screen right now. Any questions? We're actually a little ahead of schedule. I know you're terribly distressed by that. All right, so we're going to talk about classifying matter. That's the title of this notes, classifying matter. That's also a worksheet in your packet, and I'll come back to that at the end of the presentation and make sure everybody knows what you're supposed to do to follow up on this set of notes. All right, so matter can be classified. How many of you, with a quick thumbs up, have seen like a book or a movie or a TV show where they talk about things being classified? Usually in terms of like government, right? Government secrets or stuff like that. It's a sinister term, that's classified, right? Well, information can be classified in a general sense and also in a literal sense. Yes, there is such a thing as classified. It's not a fiction. The government does classify information. It's just that a lot of information is classified as public. And so it just means to put things into categories. Classifying is not a sinister thing. It just means that you've categorized something. Now I want to take a moment here to sidetrack, but I think this sidetrack is really important, because part of being a student at your age is learning how your brain works. And that's actually something that chemistry can help you with. You can learn things, and you can also develop particular areas of how your brain works. Your brain is still flexible and still developing at your age, and you are not locked in to one way of functioning, and you're not limited by the way that your brain functions. And so it's important to understand that. You might have preferences for the way that you do things, but you're not limited by those. You can learn other ways of thinking or other ways of approaching problems. Now, the reason why I say that is because one of the fundamental ways that your brain works is by categorizing things. It's an instinctive part of your brain. It's hardwired, so to speak, into your brain. You don't think about classifying things actively most of the time, unless you're asked to do it in a problem. Your brain does it automatically for you. When we perceive things around us, we categorize those, and we categorize them based on our previous experiences, right? And this is true about human interactions. It's also true about subject matter, right? And so when you learn new subject material, your brain will try to connect it to previous material, previous things that you've already studied. Just like when you meet a new human being, your brain immediately and unconsciously, without you having to think about it, will process several different pieces of information about that new person, and you will attempt to categorize that person. You can't help it. It's something that happens automatically. It's a subconscious function of our brain, but you will attempt to categorize any new person that you meet in terms of all hundreds of different dimensions: hair color, eye color, skin color, height, gender, race, ethnicity. You will attempt to categorize people that you meet. Your brain does it. You can't help it. But what I want to point out to you is, and some of you may have had this experience, when people can't categorize something new, when something new doesn't fit into the categories that exist in their brain from their previous experiences, it's a very uncomfortable feeling for a person, because your brain is not able to do one of its fundamental things that it likes to do with new information. So this can happen if a particular person that you meet doesn't conform to your pre-existing images of a particular gender or ethnicity, and it can make you very uncomfortable when that happens. The same thing is true about learning new material sometimes, and you've probably experienced that before, although you may not have thought about it at the time. And it's going to happen in chemistry as well. Your brain is going to have to create new categories rather than fitting everything into existing categories, right? Because some of the material that you're going to see in chemistry is brand new to you, and you're not going to necessarily be able to connect it to previous experience, right? So what I'm telling you in this is that in the process of your brain categorizing things in chemistry, you may be uncomfortable sometimes, meaning that you're not going to feel like you're getting it. You're not going to feel like it fits together right away. And it's really important for you to understand that chemistry just doesn't click like magic, right? You don't look at something for the first time in chemistry and I got it. It's not the way it works, because a lot of things are brand new, and you're going to have to create new boxes for information to fit into. The only way you can do that is by wading into the work and working through things, struggling through it, pushing past that discomfort. You may have heard that from some of your arts instructors. I know it's very commonly said by many dance teachers, especially. If you're comfortable, then you're not really working. You're not really learning or progressing, right? We only become comfortable with something when we've mastered it, right? And so if you're trying to learn or progress, you're going to be uncomfortable at some point in chemistry. And that's because your brain is not able to fit everything into nice, neat categories yet, right? But that feeling when it does, when you create the new categories and everything fits in, is fantastic. It's one of the best feelings when you struggle with something and then you get it and everything fits together and it makes sense. And so that's kind of going hand in hand with me having told you that persistence is really important in chemistry. So I think it's important to know a little bit about how your brain works. This is true of all human beings, right? You have different preferences for how you take in information. But when it comes to your brains all categorize information the same way. It's the same processes. So, being aware of how you learn is an important part of moving forward. And so just wanted to drop that in there. Not directly related to chemistry, but it is related to being a student. And so I think it's important to talk about. So getting back to chemistry, when we talk about matter being classified or categorized, there's a lot of different ways we can do that. In our unit 2, our first unit, we're going to categorize matter by state. And you've heard of those before: solid, liquid, gas. Quick question. Does anybody want to answer this? Let me see if anybody's brave enough to answer this. Going back to the whole universe, not Earth, but the whole universe, what is by far and away the most common state of matter? And I'm not including the fourth one, by the way. Some of you may know about plasma. That's actually not exactly the same as the states of matter that I've described here. So sorry if I cut you off, but plasma does not count in this particular exercise. Does anybody know what the most common is? Okay, so yeah, David was ahead of me on plasma. And actually, gas is still more plentiful than plasma in the universe, even if you include plasma in there. Gas is by far and away the most common state in the universe. And do you know what is the least common state in the universe? Nope, not solid, David. It's liquid. Because the universe tends to be very hot or very cold, right? Gas or solid, right? And so that's the way most of our universe is. But of course, Earth is different, isn't it? We have liquid all around us all the time, right? And so that's, from our perspective, liquid is far more common to us than it is actually in the rest of the universe. Liquid water is special on Earth. Most of the universe, liquid water doesn't exist, which is why we look for it when we're looking for life in other places. All right, so solid, liquid, gas is one way to categorize, and plasma is a thing that exists, but there's a huge difference between plasma and solid, liquid, and gas that we'll talk about later on, because the matter doesn't have the same composition in plasma as it has in solid, liquid, and gas. And that's another way that we can categorize matter. We can categorize it by composition. That's what I'm going to do today very briefly, because you've heard these terms before. So it's just a review from here on out. And this does relate to some of your work, but this will go by quickly here. So I'm going to move through these really quick. Don't feel like you need to copy or keep up. All I need you to do is just process and refresh terms that you already have in your brain. All right, so first of all, I'm going to use the word substance, and I know you've all heard that term before, but this is a more formal definition for the word substance. Yeah, that's true, Sky and David. Yeah, I mean, it's our perception of liquid. We see liquid all the time because we don't see the majority of the solid Earth. Yeah, that's a very good point. I was thinking more about perception. So, and Sky, when we talk about 76%, that's surface of the Earth. So good. More discussion going on in the chat if you're confused by that. An accurate discussion. I appreciate that. So when we talk about a substance, right, I used that word chemical earlier. Some people use the word material. I prefer the word substance. The word substance is the most important word and the best description of one unique thing in this world. And I'm going to give you a couple examples of substances that are very common that you've heard of before, just to make sure that we illustrate this point. A substance can always be uniquely identified from every other substance. So every substance in the universe is unique. It has a unique composition, and our way of describing them is very efficient in chemistry. You've encountered it before. So if you hear people use the word chemical or material, a lot of times what they mean is substance, but actually there is a conflict in there, because some materials are actually mixtures, and we're going to talk about what that is. A mixture is different from a substance, and we'll get to that at the very end here. All right, so there are two kinds of substances. They're called elements and compounds. And just like in a piece of art, an element is the smallest little piece. It's the thing that you can break matter down into, right? An element is the smallest piece of matter, or the simplest form of matter, that we can actually still identify as a substance. Now that's a weird sentence, because I haven't told you how we identify things as substances yet. We'll get to that in Unit 2. That's what Unit 2 is about. But the basic word for that is properties. Substances have properties that we can measure, right? If I break down an element, I don't get a new substance that has properties. What I get instead are just pieces. It's kind of like if I have something built out of Legos, like a house, right? And I can identify it as a house, and it has properties that make it look like a house. But then if I take it apart, all I have is pieces, separate pieces that don't form anything. Right, so that's what happens when you break down an element, right? You no longer have a substance with properties. Instead, you just have pieces. And some of you may know what the pieces are that go into elements, that go into atoms. We'll get into that later on in the year. It's not important for today's discussion. Now, we can't break down elements except to break them into pieces, but we can build elements together. And just like Legos, we can put the small structures together to make larger structures. Those larger structures are called compounds. right? And of course, elements are made of atoms, which you shouldn't take on faith, by the way. Just because your science teachers have told you that elements are made of atoms, it's important to understand why we know. And it is a know, that's not a theory. We know that things are made of atoms. We can actually see some now with the most powerful electrons, we can see separate atoms. And so that confirms the existence of atoms. But even 100 years ago, scientists knew that things were made of atoms because it's the only way that matter can behave the way that it does, right? And so I hope to present you with some of the evidence for why we know that everything is made of matter, so you don't have to just accept that as something your science teacher told you. All right, so examples of elements, hydrogen and oxygen, and I'm using these two for a reason later on. Right, so hydrogen and oxygen are separate elements. The atoms of hydrogen are not the same as the atoms of oxygen. They can be uniquely identified, and that's what we need in order for something to be a substance. Each substance has to have a unique composition. In this case, unique atoms that behave differently from each other. Hydrogen is the most common element in the universe alongside helium. That's what most stars and suns are made of. And they actually produce hydrogen and helium from the pieces, the separate pieces that we talked about that get smashed together to create those. And then those atoms can get smashed together to create larger atoms. And eventually those can join together with other atoms to form compounds. And so that's how matter is built up. And that's what we're going to break down in chemistry and learn about as we go forward. Every element has a unique type of atom, right? And so that's part of what we're going to study. And probably that's what most of your experience with chemistry has been, with things like the periodic table and the different types of elements and the different types of atoms. Some of you may have also experienced compounds, right? If so, that's great. We're going to dig more deeply into all these topics than you have in the past. Compounds contain more than one element present, and they have to be combined together chemically, and that's really important. Now, how they get combined together chemically is a topic for later in the year, and we'll cover that, although you may have studied that. And so then when things are combined together chemically, they have different atoms that are joined somehow to create a new structure, right? So it's like taking the different parts of one piece of music and then putting them together to create a different piece of music. That's an example of that. The difference between compounds and elements is that compounds can be broken into smaller substances, right? So a compound can be broken down into something that still has a unique composition and still has properties that we can use to identify it. And so when I break down compounds, I break them into elements, or sometimes I break down large compounds into smaller compounds, right? So that's important to understand. And we have more discussion going on in the chat if you're not following, and it is great. I love the discussion over there. So yeah, oxygen can be combined in different ways. David has a great point that when we say elemental oxygen, you know, there's oxygen that we breathe. There's also O3, ozone, which is a different composition than other forms. And an oxygen atom can exist by itself as well, but it's a really dangerous thing. Oxygen atoms are extremely reactive by themselves, which is why they come in pairs, as someone mentioned, in what we call elemental oxygen. So we'll move forward from that. But yeah, you guys are getting the idea for the terminology that we're talking about in that discussion in the chat. Almost done here, and we'll be done a few minutes before 11:15, it looks like. All right, so another example of a compound is water, right? So you all know the formula for water, H2O, all right? So that indicates the two different elements there, hydrogen and oxygen. I don't know how many of you know this, but that's actually where hydrogen gets its name from. Ancient Greek scientists learned that if you burn hydrogen gas, it produces water. Hydrogen means water maker. That's the literal translation of its name. And so that's important. Yeah, David, that's a good question. Elemental oxygen is O2, actually. That's its natural form, and that's why ozone has a different name. So we would call O2 oxygen, and we'd call O3 ozone. And so that different name, although they're both composed of the element, the atom oxygen. So there's actually three different distinctions there, right? Oxygen atom, right? Oxygen in its elemental form, which is O2, and then O3, which is ozone. Yeah. Exactly. There's layers to this, like we said earlier, right? And so we're going to be digging into all that stuff as we go forward. By the way, water can be separated into its elements, but you're not going to get there by just like filtering it or something like that. You have to introduce a source of energy. Energy changes matter. And so we need, in particular, the most effective way is electricity. If we apply electricity to water, it will separate the hydrogen and oxygen. And then you can actually collect them. I'll demonstrate that for you later in the year because it's an interesting reaction. So you'll get to at least see a video of that working. All right, wrapping up here with just a couple last terms. The general term particles I use a lot, right? So the particle of an element is called an atom. Right now, the general term for a compound is called molecule, but as you're going to learn, there's actually different kinds of particles that relate to compounds. So we're going to add more terms as we go through the year for those. But molecule is a good general word right now. So atoms are made of elements are made of atoms, compounds are made of molecules, and we'll get through there farther. And this last sentence is the bridge to Unit 2. Right? Particles of all matter are moving, and there's evidence for that that I'll show you. And that's a really important part of understanding how matter fits together and how it can be classified as we go forward. So we'll examine that statement more deeply in Unit 2. That's the bridge to our next major unit. Right? You already know this, but I just want to make sure it's very clear. Each element has a symbol that's on the periodic table, right? And symbol is either 1 or 2 letters. Symbols are always capitalized. That's actually really important. The symbol of an element always starts with a capital letter. So that way, if we're looking at a formula with more than one element, we can always spot each element by the capital letters that are present in the formula. And that formula is what represents the composition of a compound, right? So a formula lists each element that is in there, and also their quantities. So like H2O, right? Which tells us that 1 molecule of water has 2 atoms of hydrogen, but only 1 atom of oxygen. And they are all joined together to create a new particle that is different from the hydrogen atom or the oxygen atom when they're separate, right? And when elements combine to form compounds, the compounds are different from the elements. We don't just mix their properties together, but instead we get a new substance that has different properties, that is unique from the oxygen and the hydrogen. Hydrogen burns, oxygen helps things burn, water puts out fires. And so it has very different properties from the elements that go into it. And that's another, there are other examples of that. Last slide here, mixtures, right? So mixtures are combinations of substances that are not chemically combined, right? So I can take elements and I can join them together to create new substances, compounds, but I have to have a chemical reaction, which usually means that energy is involved because it takes energy to change the matter, right? But I can also take elements and I can just mix them together into a container and nothing happens. And then what I have is a container with a few elements in it, right? And we can do this with compounds. So for example, if I make salt water, right? I put salt in water, mix them together, and I have salt and water, right? Nothing new was formed in that process. That's an example of a mixture, right? We don't spend a lot of time on mixtures, but it is referenced in your homework. And so I just wanted to drop that slide in there. But basically, mixtures are when it's not a pure substance. And so you can get there by process of elimination in a lot of cases. Right, there is a little bit more information in the notes that I posted for lesson 6. So as always, when we have a lesson, there's always something else for you to follow up with that contains a little bit more information, right? I don't have time to cover every small detail. So you need to go back and read the notes for lesson 6, which fills in, for example, a few different types of mixtures that are also on your worksheets. Following this, you have 3 worksheets in your packet that are related to what we talked about today. They're at the end of the packet. So this is actually the last chunk of material in the packet. We've skipped over something. We'll come back to that in your cohorts, right? So you have a worksheet called Elements, Compounds, and Mixtures, a worksheet called Classifying Matter, and then a worksheet called Density Calculations. And so those are your 3 worksheets that follow this lesson. And then there's also a quiz. It's quiz 4. Okay? Now again, there's no fixed time frame for you to do those. Ideally, if you got them done before your next chunk of work is assigned to you, which is your cohort class, then that would be great, but that may not be possible. And I understand that schedules don't always allow that, especially if your next cohort is Thursday as opposed to Monday, and people have different amounts of time to get things done. In the end, just remember that your packet is due next Thursday, a week from this Thursday. September 10th is the absolute end date for this unit. You have to have everything done by then. So you have some freedom to parcel out your work as it fits your schedule. Just don't let it all slide to next week and then have a mad, stressful dash to try to get it all done at the last minute.